All right, welcome back, everyone. We're going to continue with our material. Where we left off, we were discussing the digestive glands. As far as the digestive glands were concerned, we mentioned that generally speaking, we like to refer to them as accessory organs. Most of these organs do not interact with food directly. They do help with breaking food down, but most of them don't touch the food directly. The only exceptions to that would be like the teeth and tongue, obviously in the oral cavity. But in these cases, like the pancreas, the gallbladder, the liver, they secrete their own enzymes and products to help with the breakdown process. We mentioned how the pancreas, a rather large organ, kind of covered up by the stomach. You really only see a little bit of the head region right here if you were to kind of look at the body from the front view. The pancreas not only has endocrine purposes that we learned back in endocrine system, but it has digestive purposes or exocrine purposes. And as far as those exocrine purposes are concerned, it's going to be involved with secreting a bicarbonate, which helps to neutralize those acids, and a couple different enzymes that help to break things down, break macromolecules down, like your protease, your amylase, and your lipase. By the way, I did not mention this in the last video, but there's an example of like a specific type of protease called trypsin. We don't need to get too crazy with that as far as the ins and outs of all that. All right. And last but not least, one of the major things that we discussed, bile. As far as bile was concerned, we mentioned how bile is going to be made in the liver. So this large organ here, it's going to be made there, whereas it is going to be stored in the gallbladder. So it's stored in this green small pouch. It is eventually secreted right into the small intestine. It helps with this emulsification process that is essential for breaking down fats. Starting a timer for us. Okay, so let's continue. So if we did in our video, our last video, we did small intestine, right? And we mentioned how the small intestine is not really that small. It's 20 plus feet or so in most of us. Doesn't really vary too much depending on like height or anything like that. It's usually just pretty uniform for most humans. It's like I like to always think of it like a fire hose. It's just incredibly coiled up in your in your chest cavity, um, where the small intestine is just super coiled and long. The large intestine is nowhere near as long as far as length is concerned, but it is wide. It is substantially wide. So here we see a pretty great picture. We see the small intestine in its coiled method, like I was mentioning. What you're missing is the duodenum. It would just be right up there. But from the small intestine, specifically from the ileum, remember we have the duodenum or duodenum, the jejunum, and then the ileum. The ileum is the last region, and that's going to connect directly to the large intestine. The large intestine, I have a nickname for it. I like to think of it like the scarf of the small intestine because to me, it kind of looks like it's sitting around as if you're wearing a scarf. I know we live in Florida. Not too many times do you see people wearing scarves. But that's what it kind of resembles to me. So let's see what we see here. The large intestine's function is going to be absorption of water and eliminate food residue, otherwise known as waste. So a big responsibility here, and this plays a role in homeostasis as well, is just making sure you absorb as much excess fluid as possible. You don't want to dehydrate your body. In fact, the condition that a lot of people are familiar with, where you lose too much fluids or you lose too much water, is going to be diarrhea. In it is obviously not a condition that a lot of people enjoy in the slightest, but in young children or even in elderly or in places where medical health care is not as easily accessible, diarrhea could be a death sentence because you literally can just lose out all your fluids that you may have. So we do have to be careful with that. So the large intestine, if it's functioning normally, it helps to reabsorb as much fluid as possible, keep your body well maintained. And then again, as we mentioned, eliminating food residue. So if you remember when we talked about the small intestine, not everything can be digested. Your body does an amazing job of using whatever it can. But unfortunately, there's some stuff that your body just can't really handle. And I'm going to actually talk about that in today's video as well, as far as how your body takes care of that stuff. So if you look at the large intestine, there's some regions of it that we're going to learn, kind of like there are regions of the small intestine. But the good news is the regions of the large intestine are a little bit more literal. So first off, we have the cecum. The cecum is this pouch region that connects directly to the small intestine. So it's the area where the two meet. It's also an area where we help to ferment plant material. So that whole fermentation process relies a little bit on what I was kind of teasing earlier as far as the bacteria. Next, connected to the cecum, you have this tiny little structure. It's like a little dangling string, the appendix. Now, a lot of us are familiar with the appendix for probably not the greatest of reasons, because the appendix is notorious for getting infected. And if the appendix gets infected enough, quite frankly, your best bet is removal. Now, the appendix is a vestigial organ. If you remember, we've mentioned that word a couple times in different chapters. We've mentioned how vestigial is typically indicating a remnant of our past or some sort of evolutionary background. So, for instance, when we learn skeletal system, we learn how the coccyx or the tailbone is purely vestigial. We obviously don't have tails, but an ancestor of ours likely had a tail or some sort of tail-like structure. So it's something left over. The appendix is viewed that way. There's a lot of theory. There's a lot of possible links that we see with the appendix, and I'll share a couple of them that I've looked up and have researched on my time. Some stuff has shown that it may play a role in immunity. So here's a very interesting concept. When you take an antibiotic, this is something all of us should be aware of. So you have a little bit more knowledge and vocabulary under your belt. An antibiotic, as the name implies, only targets bacterial infection. So, for instance, in the middle of the quarantine going on and a viral infection spreading, it would make no sense to take an antibiotic to fight something like COVID-19, which is a viral. There are antiviral medications, which are totally different. But in this instance, we're talking about antibiotics. When you consume an antibiotic, the purpose of it is to target specific bacteria that may be harming you. Great, no problem. But many antibiotics have side effects, especially after you consume for quite some time. What ends up happening is as it passes through your system, it eventually is going to reach the large intestine. The large intestine is home to what we call our natural flora or our biome. We have billions with a B types of bacteria. In fact, what's incredible is that even with all the technology we have, the year 2020, all that type of stuff, we have yet to be able to code or decipher every single species of bacteria that we have in our large intestine, or our flora, as we call it. And the reason why this is so hard is not just the numbers of species that are existent, it is also every single one of us have different species of bacteria. It is something very unique to us, and we start getting that bacteria from as early as when we start breastfeeding from our mothers, or even the formula if your mother didn't breastfeed. So it is something that has originated with us from the earliest time period of birth. So when we take those antibiotics, they do successfully target the stuff harming us, but unfortunately they start to attack the things that could be good for us, our healthy bacteria, as we call them. So here's where this all plays back to the appendix. The theory is, and especially with a role in immunity, the theory is that if you have an appendix, while you are under the effects of antibiotics, your bacteria actually start to migrate. Pretty cool, right? They start to migrate through the large intestine and they try to find a location that is going to help protect them from the effects of this antibiotic passing through. And it's shown that the appendix can be a pretty secure area. That's pretty interesting. The problem with that is obviously you have a massive clump of bacteria chilling in the appendix that could cause the appendix to get an infection, appendicitis, inflammation of the appendix. And as I mentioned earlier, your best bet with this is always going to be removal, because unfortunately, high levels of strong medication has a higher risk of just nuking your healthy bacteria and really causing severe digestive problems. So instead, it's going to be a little bit of a safer bet to remove the appendix. Interestingly enough, in my time period, I've actually known two people who I used to live with who had to get their appendix removed. Um, One was a roommate in college, another was a roommate post college. But two very different situations that happened to them. In one case, the guy was mentioning how he had some pain. By the way, your appendix would be like on your bottom right quadrant, so that's where you'd feel that pain coming from. But he was kind of being a little ignorant about your body's perception to pain. He was like, "It's not a big deal. I'll be fine." Well, one day he woke up at like 3 o'clock in the morning, had to call 911. Incredibly sharp pain. A lot of people that have had appendicitis, especially at the extreme versions of this, will relate to it feeling like knives being stabbed in you. Was rushed to the hospital. They took a look at him, and the doctors told him, "It's a good thing you came because you were hours away from your appendix rupturing. If your appendix ruptures, not only is the pain of that so substantial that you will pass out, but you are at risk of dying. Your body goes through a lot right at that moment. The bacteria that were just all in that area obviously starts to spread to other pivotal organs, and not a good sign." My other friend, similar situation, didn't get as bad with him. He wasn't hours away, but he started having really bad pain at night. Went in, got it removed. They actually showed him a picture, and I was able to see it. It literally, the appendix grew to like the size of I don't know, half a pencil or so. And they showed it to him. They're like, "Hey, here you go. Here's your appendix," and they obviously disposed of it appropriately afterwards. So all in all, it's not an organ that we need. It's kind of like your tonsils, if you want to think of it that way. It may have purposes. It may have had more complex purposes from a previous predecessor of ours, but in our current iteration of our species, it's there. A lot of people get it removed because of infection. All right, this is a great picture. It kind of shows us a good representation of the different regions of the small intestine. So let's go ahead and try here to label some stuff. All right. So, for instance, we have the appendix, which we just mentioned, right? The appendix is going to be directly connected to the cecum, which is this orange region. Notice that I'm going to go ahead and change the color just a little bit here. Notice that this area right here is the small intestine, right? That's going to be part of the ileum, so totally different. Then we're going to ascend upward through the colon. Here's a big point of contention. You'll hear the word colon often. Colon is part of the large intestine. So as you can tell here, all of this region is the colon, this blue, green, and yellowish color. But the large intestine is not the colon. It's a bit of a terminology issue, right? So the colon is part of the large intestine, but the large intestine is many more structures, including the cecum, the appendix, the rectum, the anus, etc. So if we follow through with our process, right, I'll just use another color to indicate some arrows of the path that this stuff would go. Let's just go ahead and use green in this case. So from the small intestine, you now have this residue that you don't really can do much with anymore. It's going to make its way into the large intestine. And in the large intestine, as we mentioned, the whole point here is that we're trying to break things down, and we're trying to reabsorb water and eventually just get everything out. Well, we first have to move things from the cecum, which is where everything enters, into the ascending colon. Ascending simply means moving up. Here's the problem. We are now fighting gravitational forces. We're going against gravity. How are we going to move this compound, this eventual fecal matter, against that area? Well, we already talked about that. Peristalsis. The smooth muscles are going to constrict the areas of the large intestine and squeeze it against your gravitational forces. So it works really well. So from the ascending colon, now we're going to reach this horizontal region. This horizontal region is going to be called the transverse colon. The transverse colon is literally just a horizontal plane where the fecal matter is just moving in one direction. From the transverse colon, Now we're going to start making our way down into the descending colon. I'll actually draw that arrow a little bit to the right. There we go. So now we're making our way down to the descending colon. In the descending colon, as the name implies, it's moving downward. From the descending colon, now we have like an interesting name. We have what's called the sigmoid colon. What works well for me is I try to highlight. Excuse me. Sorry about that. I try to highlight the shape of this part of the colon. So I'm going to try my best here. So the colon is going to be kind of like this S shape almost. It kind of resembles it to me in a sense. I mean, I can try that again, see if we get a little bit more of an accurate drawing. Even with a pen that I'm using, it's still a bit rough. Close enough. What I try to remember in my head is that this area of the colon kind of looks like a curved S in a way. So I think, okay, curved S, sigmoid works fine by me, right? So let's go ahead and just erase this stuff real quick because we have two more structures in the large intestine to name. Okay, so after the sigmoid colon, we now are essentially on the way out, right? We've pretty much completed the gastrointestinal tract or the alimentary canal, as we call it. We are now in the rectum. And then from the rectum, everything, of course, needs to exit somewhere, and it's going to be through the anus. The end. We're done. We successfully pathed the alimentary canal. As I mentioned, and it's complicated. There's a lot of steps and a lot of things going on, but overall, it's just one long tube. As I had on the Bellware question, the point of the gastrointestinal tract is to connect the mouth to the anus with many pit stops along the way. All right. So actually, this looks like a good place to stop. I definitely wanted to go through a lot of the large intestine structures, and we'll continue reviewing as we progress forward. All right. Thanks for paying attention, guys, and listening in. We'll be back for our next video.